So in this video, we are going to see about overlap save method. And when we speak about overlap save method, we have already looked into overlap add, and we'll evidently see a difference between the overlap save and add method while watching over these two videos, by which you will get an overall idea about what is sectioned convolution. So we are looking at the same case where we have the sequence 1 2 minus 1 2 3 minus 2 minus 3 minus 1 1 1 2 minus 1, which is sequence 1, and 1 2 3, which is a sequence 2, and we have to get the result of the linear convolution between them. So we are beginning with the same stage, but the method that will be followed will be a bit different. As in the previous case, we'll have to have an understanding about the variables n, l, and m. It is the same concept again. M will be the length of the shorter sequence. So here it is equal to 3. Your n, we assume it to be greater than m, so n will be taken to be equal to 4, and l, which will be guided by the relation n is equal to l plus m minus 1, will be equal to n minus m plus 1. So here 4 minus 3 plus 1, making it equal to 2. So this is our prior assumption. Like I said before, your n can be taken for a higher value, which will definitely change l, and you can proceed it in that way. But for our easier convenience, we are choosing this one, and you can follow suit or another method. So eventually we'll have to break down the sequence, and you must have noticed that I have put in 2 extra columns here, which is not by mistake, but we are going to use that, and we'll see it in the next part. So as we see over here, we are taking down the elements. We are breaking down into sequences of length L.
So we are breaking down them into lengths of 2. So you can see here as per the sequence shown over here. You can see that the first element over there is 1 and 2, which will be the first block of the data. Then comes minus 1 2. Then it comes 3 minus 2. Then it comes minus 3 minus 1. 1 1 and 2 minus 1. So we have divided them into blocks of length L. But what we ultimately need is blocks of length n. So for that, what we do here, in comparison to the overlap add method, where in overlap add method we assumed, or we considered 2 zeros at this point over here, 2 and 3. So we considered them and wrote it as 0 0 over here. But instead of that, what we do here is we consider the preceding 2 elements prior to this. So that is why we had 2 columns out over here, like the one that I mentioned before. We are using 2 columns here for that particular purpose, for the first element. So at positions minus 1 and minus 2, we have no elements, so this will be 0, and this element will also be 0. Now together they are of length 4, n equal to 4. So we have a sequence here which is of length 4. Similarly, we have to consider this sequence over here. So what are the 2 values prior to these? Minus 1 and 2. So it is 1 and 2. So 1 2 minus 1 2 makes it of length 4. Similarly, we take minus 1 and 2 over here, which makes it of length 4. Similarly, we take 2 and 3 and minus 2 over here. Then we take minus 3 and minus 1 out here, and then we take 1 and 1. So when we consider all these prior elements, we make it of length equal to 4. So 0 0 1 2 over here, 1 2 minus 1 2, minus 1 2 3 minus 2, 3 minus 2 minus 3 minus 1, minus 3 minus 1 1 1, 1 1 2 minus 1. So together we get this much sequence. Now what we need to do here is perform the circular convolution of these 2 sequences, block of data 1 and the original sequence. So we perform that circular convolution over here. So the sequence is 0 0 1 2, which will be overlapping and writing it as 2 0 0 1, followed by 1 2 0 0, followed by 0 1 2 0, which will be multiplied with 1 2 3 0. So what happens over here is we have 0, then we have 4, then we have 3, and the next element is 0, then we have 0, 0, 0, no sorry, 0, 0, then 3 and 0, then we have 1, then here 0, 0, and then 0, and last we have 2 plus 2, then 2 elements are 0. So we have the result of the first circular convolution, which is 7, 3, 1, 4. That 7, 3, 1, 4 will be written as written over here. 7, 3, 1, and 4. That will be the result of the circular convolution. It will be written adhering to the original positions of the block of data. We'll perform one more circular convolution, and the rest of them can be done by your own. So we'll do the next circular convolution, that is 1, 2, minus 1, 2. So it will be 2, 1, 2, minus 1. Then we will have minus 1, 2, 1, 2. Then we will have 2, minus 1, 2, 1, which will be multiplied with 1, 2, 3, 0. So when we do that operation, we will have 1, then we will have 4, then we will have minus 3, then we will have 2, then we will have 2, and then we will have 6, then we will have minus 1, then we will have 4, then we will have 3, then we will have 2, then we will have minus 2, then we will have 6. So the result of this circular convolution will be 5 minus 3, 2, then it will be 10, then it will be minus 4, 3, 7, 6, and then it will be 6 again. So 2, 10, 6, 6 will be written. So the second sequence begins at 0. So it is from where there that will write the sequence 2, 10, 6, and 6.
So what we do here is, meanwhile there was a small mistake to be solved. So we had 0, 0, 2, 1 over here. So when we do that particular operation, it is 0, it is 0, then it becomes not 3, but it becomes 6. So we had to correct this. A small mistake came up. So we had a small mistake here, which this had to be 6, and we will be replacing this value with 6 too. So I hope you got the idea, and we'll be performing convolution like that. In order to save time, I'm just presenting the results of the convolution over here. 7614, which is already there, 21066, which is already available there, and then we have 4. The next convolution result will be beginning at the position 2, so it will be 4 minus 6, 4, and 10, and then we will have 7, 1, 2, and minus 13, which will be beginning from this position 4, and I think we have to type it 7 minus 4, 1, 2, and minus 13, and the next result will be coming from this position 2, minus 4, minus 10, and 0, and the next result will be coming from 5, 0, 7, and 6. Now if you look over here, this is a convolution result that we were supposed to obtain: 1, 4, 6, 6, 4, 10, 2, minus 13 up to minus 3. And how do we obtain this particular sequence? So from this particular table, what we had done previously in the overlap same method was the fact that we had added these elements. Now for this particular method, what we do is we discard these two elements, or we are rather saving the computation of these two elements. So when we discard these two elements, you can see that this will become 0 and 0. Evidently there is no place for that zeros in our result because our sequence starts from 1. So this can be ignored. And when we save or discard these values 2 and 10, if we directly write down the elements, we can see that it is 1, 4. Similarly, if we discard this 4 and this minus 6, we can treat it as 6 and minus 6. Similarly, when we discard this element and this one, we can see that it becomes 4, 10. When we discard this and this, we get 2 and minus 13. Discard this, we get minus 10 and 0. When we discard, yes, this is where the next problem comes. We have nothing to discard. Okay, so we have seen here that there is nothing that can be discarded out here, and there is nothing that can be brought down to bring in this result of 4 and minus 3. Now what is missing is a sequence over here which can substitute for this value of 4 and minus 3 out of here. And now with the available result that we have, we are not able to do it. Obviously we have broken down the sequence that we had, and we did the circular convolution with them, and we got this much result. Still we are not able to obtain the entire result in the totality. So what we need to do is consider another one circular convolution to be performed. So what we do here is we take the next two elements out here. What are the next two elements? We have 0 and 0. What are the preceding two elements? 2 and minus 1. So what we actually do here is we perform the circular convolution of 2, minus 1, 0, 0. Then we have 0, 2, minus 1, 0. Then we have 0, 0, minus 1, 2. And then we have, we have 0, 0, 2, minus 1. And then we will have minus 1, 0, 0, 2. So which will be multiplied with your original sequence 1, 2, 3, 0. So when we multiply it, what we have here is, perhaps I will delete this table so that we can perform our computation. So I'm doing it over here. So when we do it, we get it as 2, then plus 0, 0 and 0, nothing much over there. Then we'll have minus 1 plus 4, then 0 and 0. Then we'll have minus 2 plus 6 and 0. Then we'll have 0, 0 and then we'll have minus 3. So the end result of this convolution is 2, 3, 4 and minus 3. So ultimately we'll be bringing it down here, which is the new convolution result 7, and the result will be placed over here. It will be 2, 3, 4, minus 3. And when we discard these two elements, we are able to bring down 7 and 6, which we already had, and the next two elements 4 and minus 3. So this is the overlap save method. So like I said before in the previous video, we need to do the tabular method first and obtain the result for the numerical that we're doing, and ensure that we are getting the same result out in the overlap save method also. If not, what we need to do at that point of time is consider another one set of convolution, which will obviously give you the result.